Welcome back, everyone, to Module 2 of our Explainer. Now, if you were hanging out with us for the first module, you know we covered a lot of the high-level, big-picture promises of AI agents. But today we are moving entirely past the hype. We're rolling up our sleeves and stripping away all that incredibly dense, complex engineering jargon so that absolutely anyone can understand what actually makes these AI agents function in the real world. Think of it like taking off the training wheels. We are going to look very closely at what actually separates a flashy, perfectly manicured prototype from a reliable, enterprise-ready system that you can actually trust.
Okay, let's dive into this. Here is our visual syllabus for today. We're covering demos versus reality, the agent loop, giving agents hands, rethinking agent memory, keeping agents reliable, and we'll wrap it all up with the operational future.
Starting right off with Section 1, Demos versus Reality. Let's really look at our expectations versus what actually happens out there in the wild. I want you to imagine, for a second, that you just hired a brilliant, absolute superstar of a new employee. They completely aced their interview, right? That interview, that's your demo. It looks flawless. But on day one of the actual job, it is a complete and utter disaster. This isn't just a hypothetical, by the way. Let me share a totally shocking real-world example from Velocity Software Solutions. So they deployed what looked like a flawless enterprise agent demo into a live production environment. But about 8 weeks later, a tiny, seemingly insignificant glitch in how the AI searched for information caused it to serve 2,400 completely incorrect answers to actual users. And it did this in just 40 minutes. Think about that. 40 minutes of runtime resulted in an auditing nightmare that literally took 6 weeks to clean up. The crazy part? The agent had basic monitoring and logs in place, but it fundamentally lacked operational discipline.
And that story right there perfectly captures the massive gap between it works and it stays working. As we look toward 2026, you might be wondering, what's the real bottleneck? Well, spoiler alert, it is not the AI's brain. The models themselves are already incredibly smart and getting smarter every day. The missing link, the real bottleneck, is the operational layer. It's that heavy, somewhat unglamorous engineering plumbing that sits right between the agent works in a perfectly controlled demo and the agent actually stays working when 1,000 unpredictable things go wrong in the real world.
Moving on to Section 2, the agent loop. Let's pop the hood and see how this actually builds.
When we strip away all the fancy marketing speak, an AI agent isn't some magic brain in a jar. It's actually just a continuous software loop. It goes through 6 distinct steps. First, it discovers available tools. Then, it defines what those tools do. Next, it takes your user prompt and makes a prediction based on the language model. After that, it executes the action, and finally, it generates a response. But here is the absolutely critical part that so many people miss. You absolutely must have an iteration cap, a hard limit on how many times it can go through this loop. Because without it, a confused model won't just stop and ask for help. It'll just ping-pong back and forth forever, trying over and over, running up a truly massive cloud compute bill while failing to actually solve your problem.
Which leads us perfectly into Section 3, giving agents hands. We need to talk about how these agents actually interact with the world.
To really grasp the challenge here, we have to contrast traditional software with AI. Think of traditional software as highly deterministic. It's like a basic calculator, right? You press 2 plus 2 and you will get 4 every single time. It is completely predictable. AI agents, however, are probabilistic. They are much more like a creative chef. Because they rely on language models and tons of hidden variables, if you give them the exact same prompt twice, you might actually get 2 completely different actions.
And this fundamental difference brings us to the concept of tool calling. Tool calling is essentially the integration layer that gives the agent its hands. It takes the AI's probabilistic intent, what it wants to do, and translates that into a very structured executable action in an external system, like pulling a record in Salesforce or committing code in GitHub. Now, the real danger here isn't the AI's thinking process. The danger is the incredibly fragile engineering plumbing required to make that tool call happen safely. Your execution layer has to handle authentication, it has to manage rate limits, and it has to catch errors. It has to act like a digital bouncer, because honestly, the AI doesn't inherently know how to securely navigate your company's firewall.
Let's shift gears to Section 4, Rethinking Agent Memory. We're going to introduce something called Governed Evolving Memory. So right now, the way most agent memory works is kind of like a horribly messy, overflowing filing cabinet. Traditional databases are usually append-only. They just blindly stuff new papers into the back of the drawer until the whole thing literally jams. And in an AI system, that causes fatal failures. What we desperately need instead is Governed Evolving Memory, or GEM for short.
An AI needs a memory system that mimics a highly organized human employee. It needs to actively read, intelligently revise conflicting facts, and, crucially, deliberately forget outdated information.
Now, what's really interesting is how this plays out over time. Let's visualize the problem. At week 0, we have a wonderfully clean start. The agent stores a very clear, simple memory. We have a website redesign project, and it's due on March 15th. At this stage, everything is great. It easily recalls that fact. But flash forward over the next few weeks. The user changes the deadline to April 20th. They also casually chat with the agent about their lunch preferences, maybe some random meeting notes. Because the traditional database just blindly appends all this new data alongside the old data, the active memory tier gets completely crowded with junk. Eventually, that old March 15th deadline and the new April 20th deadline are just sitting there conflicting with each other. So when the user asks for the deadline later on, the agent totally breaks down. It either hallucinates, meaning it just confidently invents a completely wrong answer, or it simply throws its hands up and replies, "I do not know."
To actually fix this mess, the Governed Evolving Memory framework breaks things down into 4 really simple rules, or operators. First is ingestion, adding new info very carefully. Second is revision. This means actually updating and reconciling facts rather than just duplicating them. Third is selective forgetting, removing obsolete info based on its relevance, not just how old it is. And fourth is state-modifying retrieval, which basically means reinforcing important facts every single time they are accessed, keeping them fresh. The big takeaway here? Memory correctness in AI relies entirely on actively curating the state, not just hoarding billions of data records.
Section 5. Keeping agents reliable. Let's talk about giving our systems a safety net with AI agent reliability engineering.
So, how do we keep our brilliant but highly unpredictable new employee from accidentally crashing the whole system? We give them a thick, operational manager and a safety net. The most important tool in this net is the error budget. Think of this like an automated circuit breaker in your house. You see, in AI, the absolute worst, most dangerous kinds of incidents aren't hard crashes where the screen goes blank. They are silent degradations. That's when an agent starts giving slightly wrong or increasingly bizarre answers to your customers for days on end without ever triggering a traditional outage alarm. An error budget tracks the actual quality of the answers, and it automatically halts the system if the AI starts making too many mistakes. But of course, things will eventually break. And when they do, you need a textbook 30-minute rollback playbook. It's a very strict step-by-step process. First, freeze all new conversations. Second, drain any actions that are currently in flight. Third, roll back the prompt template to the last safe version. Fourth, switch your vector index. Fifth, quarantine the corrupted memory. And finally, cautiously unfreeze the system, but only to a 10% canary group of users to test it. The industry standard here is completely brutal, but it's necessary. If your on-call engineer cannot execute this entire rollback playbook in 30 minutes at 3 a.m. when they are half asleep, your agent simply is not production ready. Another totally crucial reliability pattern we need to implement is graceful degradation. A well-engineered agent doesn't just display a giant error page and crash when a single tool fails. It degrades smoothly. It drops from Tier 0, which is the full, glorious agent experience, down to Tier 1, utilizing a faster, maybe slightly cheaper model. If that fails, it steps down to Tier 2, relying purely on document retrieval without trying to take any complicated tool actions. And if it gets totally stuck, it smoothly transitions to Tier 3, politely informing the user and automatically creating a Zendesk ticket so a human manager can step in.
Moving into our final segment, Section 6, the operational future. Let's look at where this technology is heading with deep observability.
So the crucial point is, where is all of this going? The true future is in tracking the agent step by step. You absolutely must have an incident replay pipeline. Think of it exactly like instant replay in sports. When a probabilistic AI agent acts weird, it is incredibly hard to debug because it might not do it again the second time. A replay pipeline takes a frozen snapshot of that exact conversation, secures the logs, and lets developers visually play it back in a harness to see precisely where the agent went rogue. It essentially turns a messy, unpredictable bug into a perfectly repeatable test case. And this right here is how you harden an agent over a few calendar months instead of suffering through years of trial and error.
I really want to highlight this brilliant quote drawn from the experts at Velocity Software Solutions because it perfectly encapsulates everything we've talked about today. Get the operational layer right, and the model layer will mostly take care of itself. It's such a profound shift in thinking. Success in 2026 and beyond relies squarely on your system's architecture. It relies on your secure tool execution and your dynamic memory management, not just on writing a massive check to buy access to the newest, smartest language model.
Which leaves us with one final, pretty provocative thought to ponder as we wrap up this module. Take a really close look at the AI projects you or your team are currently working on. Are you just building a shiny demo that looks amazing in a perfectly controlled presentation, or are you doing the incredibly hard, unglamorous work to engineer a truly resilient, real-world operational system? The gap between those two things is vast. But as we've seen today, with the right operational mindset and the right engineering practices, it's a gap you can absolutely bridge. Thank you so much for joining me for this explainer. I really hope you feel empowered to go out there and build AI systems that aren't just smart, but are actually built to last.